and thanks everyone for joining this webinar. I'm quickly introducing myself. I am Bharat. I am a senior partner solution architect at AWS. I work with ISVs like HashiCorp in solving customers' business problems. So today we'll go over a couple of things about HashiCorp's HashiCorp, how AWS and HashiCorp come together in scaling your adoption on cloud on AWS and to solve your scalability and other problems. So before we get into the core part of the topic, so what is a digital transformation today? So digital transformation traditionally has, which had been very centric to technology alone, has moved away from that to various parts of the business, right from your data, your OT systems, the automation system of the business, networking, and communication channels. So, like I said, it moved away from core technology, which is being only the applications and the IT, to various parts. It touches almost all parts of the business today. And IT particularly is under the pressure always to deliver applications and services to cater to all parts of the business today in a very fast and secured manner without much of an effort, deliver at scale as per the business need, and touch various parts of the systems which was not connected to technology earlier. So how do we deliver it? That has become the core fundamental challenge for IT and tech teams like us today. So what are the top priorities of business leaders when it comes to catering to this demand from the business? So the IT leaders, when it comes to catering to the demands of the business, is faster time to market. The ability for the IT teams, the application teams, and the product teams to deliver application features as soon as possible with providing a seamless experience like self-service model and pay-as-you-go model with a lot of scalability and security and governance. With security and governance put in place, where we have the observability, we have the logging, and we have all of the mechanisms baked into the solution by default, where people can come and take into a look at it in terms of if there anything is going away from the desired position in which we want the IT to run, and also able to audit the historical logs, providing operational efficiency as well, where much of the systems are automated to provision and deprovision the systems, and as well as ability to serve the IT systems at a very lower cost across the cloud. So that has been the top priorities for IT leaders in the business paradigm today. So how have we moved from a traditional way of looking at IT to today is we have moved away from a static dedicated on-premise infrastructure to adoption of multiple clouds like private cloud and clouds like us, AWS. So from looking at IT, where we have our on-premise systems with hardware and our operating systems and application services running over it, we have and then we need someone to rack stack provision the hardware systems and then install the operating system and again configure your application over and above it before it actually delivers the business features. Today we are moving away from to more easily provisionable and pay as you go, and to scalability and infrastructure which is highly scalable and resilient across the geography, to services like AWS and other private cloud install base in our IT systems. So this brings in a lot of principal change in which we have operated so far traditionally to the new and more dynamic way of working. So what are the fundamental changes of adopting this new kind of paradigm, new kind of principles? Is moving away from dedicated servers, where, like I said, we had to raise a ticket, someone had to go and rack stack the server and then power it on, and then we wanted help of multiple teams to come together to make this application operationalize before it delivers the business desired business outcomes. To provisioning of the IT services on public cloud services like AWS using infrastructure as the code, where we want to automate the provisioning and deprovisioning of the systems, scalability of the systems by just click of a button, by all the codes which is written in our IDE, without depending on someone or without wanting to raise a ticket to go and provision system for us. And we had, from a security perspective, we had very static networking with a high trust IP based solution, where we were dependent on all the networking layers and the physical components to secure our environment. To move away from that to a shared services model, where we know our systems are running across the public cloud and the private cloud, and securing it right from the security network perspective to an identity based model, where we know the persona of the person who's accessing our systems and what level of permission is allowed or disallowed to be performed on the systems. And like I said, networking again was completely static in the traditional model. To move away from it to in a very dynamic and an agile model, where we provision and deprovision the network and enable the connectivity to our applications in a service-based model using microservices and various other principles which is associated with it. So that's how the principles have changed right now from a traditional model to the new principles of working. And today we'll concentrate more from on the operational level, that is how we use Terraform on AWS to enable the infrastructure as code part. So before we move into this model, what are the various stages which we typically follow to adopt, standardize, and scale? So the main theme which comes across all of this is standardizing our way of provisioning and operating environment on cloud, right? So earlier we used, when we start adopting to any services or application on cloud, we will seek the help of, or the developer teams and the ops teams need to provision and deprovision the system on cloud for a particular application or a service. And then we would like to standardize the operation, security, networking, etc., by a common theme of adoption of service, adoption of how the way we connect, how we secure our application, and how we bring in observability, resilience, and availability into our application. And then we want to make it a standard across the board and across your private and public cloud adoption, which is very standardized, and all our teams across the firm knows that this is the way we have to operate, and this is the way we have to provision and deprovision our systems. And this is what we call as blueprint. So right from tactically, provisioning and self-provisioning of resources based on our requires and the business needs for a particular application, to moving to an enterprise level scale by blueprinting or the entire model of provisioning of the system and operating the way we want it to is done by the way of blueprinting. And Terraform comes in very handy and enables us to write all the codes and now also blueprint this entire templatized model on operating on cloud. So just like the way we would want our the assembly line to be standardized without any hassles, the way we want our assembly lines to be streamlined for us to consistently deliver the kind of cars, or just an analogy here which we see on the screen, the kind of cars and the kind of output which we want to deliver in a factory. We want to standardize with a set of tools to deliver consistent and secured way of operating the systems on cloud or multi-cloud. So that's how Terraform and AWS come together with to make this feature enable for our technology systems. So we will focus on how we make this entire assembly line standardized, templatized, and the way we create blueprint along with Terraform on the provisioning layer of the infrastructure today. So during the rest of the sessions, you will hear from G, who will be walking you over this entire functionality and features, how all of these things come together. Over to you, G.
All right. Thank you, Bharat. Let me just share my screen first. All right. So before I begin, just a very quick introduction of myself again. So I'm Zhihao, the Partner Solutions Engineer here at HashiCorp. Very delighted to be here today to share with you about how we can scale your adoption of AWS using HashiCorp's Terraform. Right. So I'm going to spend the next 20 minutes or so to talk about in details how we're going to do that in terms of enabling your automation of doing your cloud infrastructure provisioning on AWS. So just a very quick summary of what exactly is Terraform. So Terraform is essentially HashiCorp, our version of infrastructure as a code tool. The best thing about Terraform is that it is a multi-cloud, a multi-provider platform. So meaning to say that you can define your entire software, your entire infrastructure using a codified template, and that can allow you to spin it across different cloud providers, right? And AWS is one of the examples, and different platforms as well, even your private infrastructure. So the best thing about IAC code Terraform essentially is, of course, it is software defined, makes it very reusable and repeatable. And because everything is in a codified template, so it allows you to put everything into an automation workflow, as well as put it through a distributed version control system, so that you have a single source of truth in terms of tracking whatever changes that is being made to your infrastructure, right? So in essence, this is what Terraform is. Essentially, it is an ISD tool, and these are the benefits that it entails, right? So with that, when we talk about how do we scale our infrastructure provisioning on AWS, which we learned earlier on, like what Bharat mentioned in the cloud world, let's first take a look at how infrastructure is being provisioned traditionally, right, in the pre-cloud world. So if you look at the traditional way of managing IT services, essentially, let's take a look at, for example, there are different stakeholders involved, different personas, right? You perhaps have your infrastructure team, you have your networking team, you have your security team, for example, right? And then whenever, for example, someone wants to provision, a developer, for example, wants to provision an infrastructure to deploy his application, he will typically, for example, raise a ticket, right? It's a very manual process. He may perhaps raise this request using email, for example, right? And that will go through the infrastructure team, the networking team, the security team, and there is a lot of approvals, a lot of reviews, a lot of validations in place. So, before the actual infrastructure gets provisioned into the respective environment, right? Be it your development environment, be it your staging environment, or even your production environment, right? So over here, you can see that that's where the different arrows, this different line, the red line comes into play, right? There's a lot of back and forth between these different teams before the infrastructure gets provisioned. And that is a very long and tedious process. And that is it does not serve well in terms of the time to value of provisioning your infrastructure, right? So if you take a look at this traditional way of provisioning the infrastructure, it typically, because of the sheer nature of how it goes through the different stakeholders, the different review process, making sure that the entire infra complies to the organization's security requirements, for example, it typically takes about days or even weeks before the actual infrastructure gets provisioned, before the team can actually deploy the applications to the environment, and then you move on to the day two operations, right? And that's not where we want to be, right? In terms of the time to market, in terms of how we should manage our infrastructure in this modern cloud era, right? Where we want to be essentially is we want to have a great synergy between the different teams, right? Between the different processes. So, and this is what we talk about in terms of having everything as a code, right? You talk about your infrastructure as a code. You talk about automating your entire policies as a code as well. You talk about automating your golden image pipeline to have that secured hardened image. Before, you provision your infrastructure, you put everything through an automated platform, and then it's get provisioned, right? And that really helps in terms of making it more efficient, helping you to decrease the time required to deploy your infrastructure from days to weeks to a matter of hours and a few days, right? So there's an increased time and productivity over there. So that's where we want to be, right? In terms of how we're going to scale our provisioning on AWS, for example, right? So the IT traditional workflow does not serve well in this cloud era, right? I mean, it's a very waterfall approach. It's very sequential. You go through you raise a request in a very manual way, perhaps through emails. You go through the different stakeholders, and that's not served well in this cloud era, right? If you remember the 3 top priorities of the IT leaders have today, number one, definitely they want to have a faster time to market, and at the same time, even if they would like to move fast, they do not want to have any compromise in terms of the security and governance of their entire IT environment. And of course, in terms of managing the operations going forward, right, in day 2, they want to have a certain element of efficiency over there, right? So with this, we can clearly understand that the traditional way of managing this IT services request of provisioning infrastructure, for example, does not serve well in this modern cloud era, right? So where we want to be definitely is to incorporate the entire DevOps workflow to have a fundamental change in how we're going to transit from moving how we provision and manage our IT infrastructure traditionally to a more modern way that is well suited for this cloud environment, in this cloud era, right? And that is essentially what we call it as a DevOps way, whereby we try to synergize and harmonize the entire workflow together, right? So it's a very it's a very code-driven kind of approach. You have everything as a code, right? Your policies as a code, your infrastructure as a code. You store because everything is in your code, you store everything into your version control system, your remote version control system. It can be your GitLab, GitHub, or even Bitbucket, for example, and you integrate it with your IAC platform, which gives you the automated flow of provisioning your infrastructure, right? So this is you're transiting from manual way to a more automated way of defining your entire infrastructure, not just for day 1 itself, but also in terms of day 2 of how you manage your entire infrastructure lifecycle, right? So that gives you a better time to value of this entire process, right? And it's in line with what the top IT leaders look at today, right? In terms of time to market, in terms of incorporating security into this entire infrastructure provisioning lifecycle, as well as having more and better, operational efficiency, right? So that's where we want to be, right? To move from this traditional way to this DevOps way, right? And that's how HashiCorp works as well. That is our philosophy, and that's what we are our mission is, right? Our enterprise way is we really want to have a combination of the people, process, and technology so that you can have this very harmonized and single unified platform to deploy your infrastructure on AWS, right? So if we look at how HashiCorp does it to synergize this entire people, process, and technology way to move from a very manual way to a more automated way of provisioning your entire infrastructure workflow, one of the ways that we do it, in fact, essentially is your team still exists, right? You still have your infrastructure team, your networking team, and your security team, right? But now we give each team their own IAC pipeline, right? Your infrastructure team perhaps can have their own infra pipeline. Your networking team can have their own networking pipeline. Your security team, for example, can have their own security pipeline, right? And in each of these pipelines, because they are confined to these respective teams, they can store their, source code, their templates in their respective version control system, right? And with that, they just have to, manage their own IAC pipeline, and that can harmonize well together, and collectively it can allow you to have this entire automated workflow to really increase this time to value and productivity increased in terms of managing your entire infrastructure provisioning request, infrastructure provisioning workflow, right? So that's how it works. And if we put Terraform Enterprise into play here in this, using this concept of structuring your different teams with their own respective pipelines, and that's where the Terraform Enterprise come into play as well, right? All these pipelines reside in Terraform Enterprise itself, and when the different teams do any code commit of their changes, you automatically trigger the Terraform execution in terms of the Terraform plan, which essentially is just like a run-in to give you a view of what you're going to provision into your entire infrastructure and entire resources on AWS, for example. but it's not going to do the actual execution, right? It's just a view for you to review and validate what you're going to provision. And then you can actually do your Terraform apply, which will actually communicate with AWS API to do the actual execution and provisioning of the cloud resources on AWS, right? And in between that, definitely we talk about not wanting to compromise in terms of security and governance checks. That's where we can have cost estimation come into play, as well as policy as a code coming into play in between the plan and apply stage, so that we can actually shift the entire security to the what we term it as a shift left security approach, whereby we want to start scanning our IC templates. We want to make sure that whatever infrastructure that we're going to provision complies to the whatever organization policies that you may have at the very beginning, at the build stage, rather than we leave it at the runtime after the infrastructure is being provisioned, right? So in terms of Terraform Enterprise, that's how the entire thing works, right? In terms of enabling this automated workflow, this DevOps way of provisioning your infrastructure, right? So in the concept of the IAC pipeline, that's where the Terraform's, using Terraform's terminology, that's where workspaces come into play. Each of the teams have their own different IAC pipeline, i.e. to say their own workspaces, and each different workspaces are connected and integrated with their own respective remote distributed version control system, VCS in short. And then each of these VCS, once any of the respective teams to deploy their applications into the version control systems, you'll automatically trigger the entire Terraform run, whereby the Terraform Enterprise workspace will be triggered to do its run of the plan and then the apply. And of course, there is the policy checks into play, right? The policy checks can be checking your cost, as well as checking whatever compliance requirements. Maybe, for example, you want to prevent your infra from opening up to the entire public internet at RDP access or SSH access at port 22, as for example, right? You can prevent this kind of things from happening to your infrastructure before it gets provisioned into your actual runtime environment, which can be AWS, for example, right? So in terms of the concept of a different respective pipeline, that's where workspaces come into play. And one of the things that how you're going to scale eventually after that, one of the ways is, of course, we have this concept called the private module registry, whereby it's really fundamented by the whole idea of the producer-consumer model, whereby your producer can be someone who knows AWS very well, for example, who knows the entire cloud architecture, cloud infrastructure very well, right? And someone who knows IAC very well, who knows the entire DevOps very well, for example, right? So this person can be the producer, whereby this person will write the IAC templates, what we call it as a modules. Modules are essentially a reusable template that once it's written, you can actually propagate it and share it across different teams in your organization. And once you tag it, you release it, then you can upload it as a private module registry, which is only available to your organization, but it's reusable for your many of the teams in your organization, right? And with that, your developers, for example, they are essentially the consumers, right? All they need to do is, just consume the modules, right? The modules that's already pre-written, which have all the templates, all the templates required, or for example, even baking security required. All they need to do, for example, if they want to deploy an application, let's call it fancy app application, for example, right? All they need to do is really just consume from the module, maybe state what is the VM size, the VM type that they require. They put some tagging of the different environments and what is the region they want to deploy this into in AWS, for example. And with that, all they need to do is specify the end state that they want. And this entire automated triggering of this workflow will happen in Terraform Enterprise automatically in a very automated fashion. And the developers will be able to provision the resources they required and then they can go on to deploy their applications, right? So essentially, that's how Terraform Cloud for Business as well as Terraform Enterprise come into play in terms of enabling this DevOps automated workflow, right? As opposed to what we learned about previously, which is the very manual way, right? So to deep dive a little bit more into our workspaces, we learned that essentially it is a encapsulation of the different teams' IAC pipeline. One of the ways of how we can strategize to structure our workspaces is we can structure it based on the different applications, for example, as well as we can also structure it based on the different environments, right? So essentially, workspaces is a very the combination of workspaces, the combination of VCS, which allows the different teams to collaborate and work together, and then they can respectively trigger the automated pipeline. That is actually how you would scale, right? When you run and deploy your applications on a very, very large level, which requires you to collaborate between your different teams in your organizations, right? So that's how workspaces come into play in tandem with your version control systems, as well as your team management functions, for example, in terms of restricting the permissions between the different workspaces, right? And all this, right, is some of the tools and features that Terraform Enterprise or Terraform Cloud comes into play to allow you this scalability when your organization start to scale, right? As you start to adopt more and sophisticated workloads on AWS itself. Right. So, I mean, just drawing on the fact that we talked about earlier, you can structure your different workspaces based on the different workloads, as well as based on different environments to allow this scalability of adopting your cloud infrastructure provisioning on AWS. Right. So, adding on to the fact that besides workspaces, because workspaces, every workspaces, they have their own state file, right? And state file, essentially, it contains all the information that Terraform knows that is managing in the AWS environment, right? Because all the state file is stored remotely in Terraform Enterprise, Terraform Cloud itself, and it is encrypted at rest. So with this, it allows different teams to better able to collaborate and work together, right? Because your state file is now being stored in a remote location. So whenever the different teams, when they start to do their code changes, the infrastructure code changes, commit to their VCS, everything, because the state file is really stored in a remote location, so it allows this better collaboration between the different teams in a better, in a more efficient fashion. So that's how the state file and the entire workspaces come into play, come into harmony to allow you to scale your adoption of AWS itself, right? So to list an example, I mean, we shared a bit about how Terraform Enterprise come into play to allow you to scale your provisioning on AWS itself. We talk about workspaces, we talk about the VCS integrating with Terraform Enterprise, we talk about how the different teams can strategize their workspace strategy to manage the different resources that they require using workspaces, and how state file is stored in different workspaces, and they are stored remotely in Terraform, which allows you for better collaboration. So now let me just give you an example of some of the collaboration patterns that organizations can start to work at within the different teams at the enterprise level, which allows you to scale, right, with the adoption of AWS, right? So for example, right, over here, you see that you have a Terraform Cloud and Terraform Enterprise, right? And in each of these workspaces, for example, you have your networking team, right? We have their own respective IC pipeline, i.e. to see the workspace, right? And they stock all the required AWS, the networking resources templatized into a code, and install it into their distributed version control system, right? And this version control system is integrated with the workspaces, right? And some of the resources that this networking team can be responsible for developing is, for example, your elastic load balancer, your net resources, or your VPN gateway, for example, right? Even your VPC resources as well, right? So they will be responsible for deploying all these networking infra resources in their own respective IAC pipeline, right? Which is essentially their workspaces, right? And then you have your security team, for example. Your security team will be responsible for crafting out the policy as a code to ensure that whatever resources that is going to provision by the networking team, for example, complies to the organization's security and compliance requirements, right? So they will write their own policy as a code, right? Which allows you to have these automated guardrails to check that, for example, your networking resources that you're going to provision AWS complies to whatever security requirements that the organization can have, right? So they work independently, right? But although they work independently in their own respective workspaces, but Terraform Enterprise can bring harmony to these entire different teams' responsibilities, so that they can form a very unified platform to deploy your resources on AWS, right? Without compromising your security, as well as without compromising your efficiency of managing your operations, as well as your time to market, right? Because you can provision your resources leveraging on what the cloud is meant for, right? On-demand computing, you can provision your resources in a matter of minutes, right? So that's how the different teams that work together. Over here, you can see the illustration, right? There is a networking team and there's a security team doing the policy as a code, right? And for our policy as a code, we have different enforcement levels. We have advisory level, which is mainly just informational purpose. It does not stop your infra from getting provision. And you have your soft mandatory, right? It does stop it from provisioning, but you can actually overwrite it, so you still allow the provisioning to occur. Or you have your hard mandatory, right? That means it's a hard stop, right? Your team, whoever, for example, your networking team in this case, they have to fix whatever changes, whatever policy sound out that was being flagged out. They have to fix these changes before it gets allowed to be deployed into the environment, right? So these are the different enforcement levels that you can set, and it's very flexible to you based on how your organization works, of what kind of enforcement levels that you want to set, right? And lastly, you have your developers, right? Your developers will be the one that's responsible for the application workspaces. For example, they will spin up the VM resources that they require, right? The EC2 resources that they require to deploy their applications into. And let's say if they want to have a template, right? A VM image they want to reference from a single source to template, so that you can make sure that you're always provisioning from a secure image. You also can make use of our Packer tool, which for Terraform, it works in tandem, where Terraform can reference from Packer, which Packer is used to build the VM images, so they can always ensure that you have, you know, the EC2 instances that's being provisioned from, the AMI is always from a very secure image, right? And bearing in mind that even though the developer team have their own workspaces to deploy their respective resources, it is still under the governance of this entire policy as a code automated guardrail, right? So the EC2 also has to comply to these governance checks, which the security team is responsible for building and writing the policy as a code, right? So these are some of the examples of how the different teams can actually work together in their own respective IAC pipeline workspaces, and they work in tandem, you know, to provisioning their respective resources, which essentially represents the larger environment that you will provision to deploy your applications on AWS, right? So this is an example. And with that, I also want to take you through the journey to this cloud operating model. You know, as you scale, as you move along your journey on cloud, what are some of the things that you have to take note of, right? And Terraform is well equipped to really meet your growing needs as you start to scale your adoption on AWS, right? So earlier on, we learned that there are different stages that the teams embark on, right, as they move through their adoption in cloud, right? Typically, they start to adopt in stage one. That's where they start to, you know, realize the benefits of what the cloud can offer, right? So they use different teams or work in a very siloed ad hoc way of using Terraform, for example, to leverage on the benefits of what the cloud can offer in terms of automation, right? But in stage two, let's say if you want to start to scale, you do not want your teams to work in silo. You want to put in place, you know, certain governance requirements, governance policies to make sure that whatever AWS resources you're going to provision, it always is within your cost control that the organization require, as well as it meets the organization security requirements, right? So that's where stage two come into play. And that's where our Terraform Enterprise comes into play as well in stage two. And in stage three, as your organization starts to scale, right, as they want to, you know, bring about this automation to your private infrastructure, for example, your on-prem data center as well. That's where Terraform Enterprise can also work, right? Because Terraform Enterprise, we have about 3,000 plus of providers that allows you to deploy not just to AWS, but also onto your on-premises infrastructure itself, right? So there is this natural integration there that allow you this automated provisioning, right? So you can, as you can see, in terms of provisioning your resources in a very automated fashion on AWS, as you move along these different stages of your life cycle for your organizations, the Terraform is well equipped to meet your needs as you start to scale, right, in these different stages. And one of the very last slide that I want to bring together is to bring everything together of how you're going to scale your adoption of AWS. And essentially what this means is to meet the enterprise requirements of, adopting AWS and provisioning your resources in a very automated fashion, right? And if you recall, one of the things that we talked about earlier on is we want to harmonize the three so-called processes in terms of the people, whereby you have your different teams, right? And these different teams have their own respective IAC pipeline, which is in the form of your workspaces, right? And that is how you're gonna allow your processes and your tools to work well together. And in terms of your a life cycle management of your infrastructure resource, right? Not just in day one, but in day two, how after the provisioning it occurs, how are you going to manage the life cycle of this entire infrastructure resource to make sure that it always complies to your security requirements. And let's say if you need to decom in infrastructure resource, you can always bring it back to this entire IAC workflow to manage this entire infra lifecycle for you as well, right? So that's how HashiCorp works as well in terms of how we bring the entire people, process, and tools together to bring about this automated workflow as you start to adopt, AWS at scale, right? So to bring it together, that's how the entire IAC workflow works. And with that, actually, I actually come to the end of my presentation, right, to talk about this scalability of using the IAC automated workflow to scale on AWS. I'll be happy to take in any questions at the end. And with that, over to you, Yogesh.
Thank you, Zihao and Bharat. Nice presentation. So folks, if you have any questions, please drop them into your Q&A tab now. Zihao, I have a couple of questions. First one is, will a new state file be generated for each of the workspace?
So when you start provisioning, when this is your first execution, you will generate a new state file. But as you start to, do your ongoing provisioning and everything, the state file will remain. It's just that whenever you do your plan, for example, your apply, for example, Terraform will always update the state file accordingly. So there will not be any so-called new state file that generates, but the Terraform will generate the state file accordingly and store it in the workspaces itself.
Thank you, Zia. Next question, is there a one-on-one mapping between workspace and respective state files? If yes, how does Terraform ensure that there is no conflict in code between two workspaces?
So each workspace have their own state file, right? And they are respective to their different executions, right? So one of the best practices that we normally recommend to the different, many of our customers out there is that how you strategize your workspace, how you want to segregate your workspace is a very important consideration when you start to embark on Terraform itself. So that's why earlier on, if you see the analogy that I gave, one of the ways that you can structure your different workspaces is to put it across the different teams, right? For example, you have a networking team that will spin up your networking resources. You have an application team that will just spin up the EC2, the compute resources, essentially to deploy the applications, right? And then each workspaces, the state file, they are not viewable to each other, right? Unless you give permissions for one workspaces to reference another state file. For example, let's say if you want to provision your EC2, you need to reference the networking resources that was actually provisioned by the by the networking team, right? Because you need EC2 essentially needs to be provisioned into a VPC resources. So there are access controls in place that we can set in Terraform Enterprise as well to provide this level of fine-grained access control, right? So with that, you can rest assured that based on this, how you structure your different workspaces, the strategy of that, there will not be any conflicts.
Thank you, Ziha. I have one more question. Does Terraform Cloud support importing manual changes, which are non-ISC Terraform changes made in AWS backend back into Terraform config?
Okay, so if I understood your question correctly, based on my understanding of this question, I think it's trying to say that perhaps you have already provisioned certain resources in a very manual fashion using the AWS Management Console, for example. And thereafter, you have decided to embark on ISC to leverage on Terraform itself, right? And now the question is, how can you bring this entire infrastructure that was already provisioned under the management of Terraform itself, right? So if I understood the question correctly, the very simple answer is yes, you can certainly do so by using the Terraform import functions.
Thank you, Ziha. I have one more question. Is there any limit of resources that a TF state file can have? And what are the possible reasons that a state file will be corrupted?
So if I understand, so I'm trying to understand the question of the limit of the resources. But I mean, the very simple answer is there is no limit of resources, right? It all depends on your configuration file, and the state file will be, updated accordingly based on your Terraform code, what you have actually configured and written in your code. So in that sense, there is no limitations. And if the concern is about scalability, in terms of whether or not you can provision and manage, huge amount of resources, there is definitely no scalability issues because we do have customers that have thousands of workspaces that we support as well. So scalability is definitely not an issue over here, right? And in terms of corruption of the state file, one of the guidelines that we can have is never ever, amend your state file on a very manual approach whereby you go inside your state file and you manually change anything, because that can definitely lead to corruption of the state file. And state file, we know that is a very important piece of information that Terraform relies on to know what is the state of the world that it's actually managing in, right? So number one, never go inside to manually change your state file. Number two, with that, right? Actually, there is no way that the state file can get corrupted if you're following the best practices of how the Terraform Enterprise works, right? Because now you're not using the open source flavor, right? Whereby the state file, if you use the open source, the state file will be stored locally, and then you need to, if you want to allow collaboration from a larger team perspective, you need to scaffold different solutions into play, right? For example, you store your state file in S3, for example, right, in a very remote, and you need to put a lot of scaffolding of solutions over there. So our recommendation to you is really just leverage on many of the engineering efforts that we actually put into place to allow this to store your state file in Terraform Enterprise itself, so you can ensure that your state file is always in a non-corrupted state. Yeah.
Thank you, Zia. I have one more question. I knew Terraform import function works in the Terraform open source version. Does this work in Terraform Cloud as well when importing manual changes made in AWS portal to a resource provision using Terraform?
Yes, I mean, you can use the Terraform import to work. It works as well. And the only difference between the Terraform Enterprise, Terraform Cloud versus Terraform open source, of course, is Terraform Cloud for business as well as Terraform Enterprise essentially is our commercial offerings, right? Whereby we want to support organizations at the enterprise level. And we will talk about enterprise level. We are talking about high availability. We're talking about collaboration between the different teams on a very large scale, right? So there is definitely no issues in terms of how the entire workflow works, how the entire fundamental concept of Terraform works. Essentially, is the same. I hope that answers your question.
Thank you, Ziha. So folks, if you have any questions, please feel free to drop into the Q&A tab. Now I don't see any pending questions in Q&A tab. If there are no questions, thank you, folks. That brings us to the end of our session today. We hope you found it useful. As I mentioned earlier, this session will be recorded and we'll send you a copy of the recording via email. Before we go, I would also like to remind you for the next webinar, which is coming up, there is a QR code on the slide. Sorry, there is a question. Okay, Zia, sorry, there's a question. How to keep the historical log?
So I may need to understand the question better. When you say historical logs, what kind of logs are you referring to? Is it referring to the changes that's actually made to the source code itself? Because if that is it, everything is already being captured by VCS itself. So in terms of historical changes that's made to the source code, that's really well in place with the entire gig-based workflow. Yeah. So I may need to understand the question in deeper details. Essentially, what kind of historical logs are you intending to keep?
Any changes of infra?
Yeah. So any changes of infra is definitely captured by the entire gig-based approach, right? Because one of the fundamental workflow of how Terraform works is we want to store everything into our version control system, our remote distributed version control system, right? This will be our single source of truth, right? Essentially, it acts as our documentation as well in terms of whatever changes that has to be made to the infrastructure. We can always look at this historical records because the changes are being captured by gig, right? So that is definitely there. And for example, if you want to revert back to the previous version, let's say if the latest version have any issues, it's very easy for us to do so as well. It's simply just relying on this gig-based workflow. So the answer is yes.
Okay, one more question, Ziha. Is Vagrant wrapper supported?
So Vagrant is different, so-called tool as opposed to Terraform. So coming from HashiCorp, definitely there is if you make use of whatever features that we offer, I would say just go with Terraform. Yeah.
Let me check if there are any questions. I think that should be all. Guys, any other questions, please feel free to drop into the Q&A. I think, yep, that should be all. And as I was saying earlier, before we end this webinar, I would also like to share the next webinar, which we are doing with the AWS, securing your AWS environment from the ground up with HashiCorp Vault. In this webinar, you will learn how you leverage HashiCorp Vault to manage the entire lifecycle of secrets using AWS, which includes creation, deletion, expiration, locking, and rotation of access and secret keys, a crucial component in building secure cloud infrastructure. If you liked what you heard today and want to learn more, please visit Learn pages on our website, which you can find at learn.hashicorp.com. Finally, thanks again for joining us today, and big thank you to Zia and Bharat as well. Enjoy your rest of the day. Bye for now.